So I'd now like to introduce the next speaker, Professor Martin Viesbeck. Martin is head of the research unit in Physical Oceanography at GEOMAR Helmholtz Centre for Ocean Research in Kiel, and professor at Kiel University in Germany. So Martin will speak about environmental science and sustainable development.
Thank you very much. Well, thank you, Chris. And are we having a microphone? Yep. Maybe, yeah. Thank you for being still with us and with me here. So I've used the summary slide, and the title is down there, Environmental Science and Sustainable Development. And as you just heard, I'm also a marine scientist. There's a bit of a marine bias here, but I'm sure through the balance of the week we'll sort that. And what I want to discuss with you is a little bit how we can use our science, how we can use remote sensing to really understanding the planet in the context of sustainability, sustaining our future. And I put two little characters down at the bottom there. That's supposed to be the connection to us humans. And let's see how we go. Here you see an image a little bit shady, but I think you can still see it. It's the night lights of our planet. This is also a remotely sensing product. I believe it's from one of the space stations. And I think what you notice is that whenever there's a light, there's an affluent version of society living. There are some areas which are highly populated and not so affluent, so don't use so much night lights. But in general, you notice that people like to live near the coast. And I think Annie hinted to that, so the coast is even farther growing as we go into the future. And that the main reason is not just because people like the beach, which I'm sure you do, but it's because actually the coast allows global communication for one, but that's easy because we can transmit that, but it's also the global trade. So the global economy has to do with global trade. Global trade goes by ships. Ships go to ports. If you live clear of the port, that's good for you, for global economy. So that's one of the reasons why people move closer to the coast, because it's easier for them to participate in the global economy. It's actually the main reason of it. Now, if you look at some numbers, and I think Annie mentioned some of them, here's just my graph of that. That's the world population over the last century, or since 1950. I was born here somewhere in the 60s, and between then, 3.5 million, and now, 7.4, the world population has doubled in my lifetime. Which is a rather amazing thing that there's certainly never been before in the Earth's history that the human race has doubled in size. And I think it's an accomplishment because we managed to do something around health. We managed to get access to energy. We managed to provide ourselves with food. And despite all complications, but the life that we live today, each and every one of you here in Frascati, is so much nicer and so much more comfortable, even the poor people in Frascati, than those who live in the mansion that we're staying at the night, right? Where the kings and the queens of 2 centuries ago had much worse life than the poorest people in Frascati today, and certainly, but orders of magnitude is worse than most of your lives, right? So it's an enormous accomplishment on the one hand, but obviously that accomplishment also goes with challenges. If you look into the future, by the end of the century, the most likely projection is 10 to 11 billion people, so another 3 or 4 more. There are some high and low ranges. The high ranges would have to do with some ways to figure out better solutions. The low range could be diseases or wars, but there's a very high probability that we're going to hit the 9 or 10 billion people at the end of the century. So what does that actually mean? It means a growing population has increased demands on the planet, in the ocean space, by food, transport, materials, energy, and so on. And if you take that in your head, so more people, more affluent, everybody wants to live like all of you here in this room, that means we probably need to think about that, how that is going to work with one planet and one ocean. And that's in essence what sustainability is all about. It's thinking about how can we imagine a world with 10 billion people living like we live in one planet. And I think the science basically says the development, human development, needs to, I mean, there's no way out, to respect planetary boundaries. And now at ESA, they're working on discovering other planets. Steve Hawkins, I like a lot, right? But Steve Hawkins in his late days always said, we must work harder on this. We must leave our planet because it's going to be too tight for us. I think on that one, I don't disagree with Steve Hawkins and many other things I do, right? I think we probably have to think about how we can manage what we have more cleverly so it goes around for 10 billion people. Because there are boundaries. I mean, we heard about climate change, the biosphere integrity we'll hear about this week, land use change, freshwater use, biogeochemical flows, ocean acidification was mentioned, aerosols, landing, and so on. So there's many things which are there are some limits to what our planet has to deliver to humanity. And I like this graph. It comes from the development community, what it basically means, scientifically speaking, what is then the safe and just operating space for humanity? And what this means is outside, that's the planetary boundaries, and inside, that's you and me. We want water, income, education, resilience, voice, jobs, energy, social equity, gender equality, health, and food. Everybody on this planet wants that. More people, that means that demand grows. The outer circle stays. It's begun to come tighter. Right? And so what is that safe and just operating space for humanity? And I think to address that, to me, that's first and foremost an academic question. We at universities, research centers should have an answer to that, should look into this. This will be a science of complex systems. That is not for one specialist to do. This is a group effort, right? And the sustainable development goals, which I speak about in a second, are just sort of the political frame around that. And I want to speak mostly in my first talk about this. So at the United Nations, our states have realized that that's a challenge, and they developed the 2030 Agenda for Sustainable Development. There's been a 5-year process around it, and I'll show you the goals in a second. So what we're doing where I live in Kiel, we're looking at these sustainable development goals from an ocean perspective. Now, we can look at it from a land perspective, from different ones, and we've published a few papers with an international organization that I mentioned after the lunch. And basically, what we're trying to do is, collectively, I think, we're trying to understand the human pressure on the system. Annie has shown very elegantly one element of the human pressure, that is the warming, introducing sea level rise, that happens on the coast. It's one of them. This picture shows another pressure, which has to do with environmental pollution. When you go around coastlines these days, each and every one of you have noticed that, they're becoming more full of litter, plastic in particular, but others too. The next question is, how can we support resilience? Because if we want this planet to go around for the next generation, we have to think about how can we build cities resilient, lifestyles, things like that. So it's about resilience. Was what we're really looking for. We want to be resilient against climate shock. We want to be resilient against sea level rise. We want to be resilient against diseases or into food shortages, right? So resilience is another thing I think we want to work on. And last but not least, I think most of us think of the environment as a resource that gives us prosperity. Materials, energy, food, all of that. So it's about the prosperity that we can collectively take from our environment, but in a way that also safeguards the next generation's prosperity, not just my prosperity. And that is already a question, whether our lifestyle is actually doing that, whether it allows us to give prosperity to the next generation and the generation after that. There's some really scientific questions around that. So how do we go about that as scientists? And again, I'm always giving ocean examples. So first and foremost, I think scientists love to discover the environment. I think most of you are probably in one way or another excited about finding out something new. And Annie, I think in her lecture, gave a great example. When you put everything together that we know about sea level rise, it's another way of saying maybe there isn't too much to be discovered fundamentally, because we can budget all the things that we know, but you never know, right? But in many parts, deep sea here, there's lots of things we have no idea of. So there's still discovery happening, but I'm also sure it's true for the land surface. We're not done yet with discovering new things, right? Still something that we do. Now, once we've discovered and understand a little bit, then what we're trying to do is put our discovery into understanding. Now, in my world, physical oceanography, we can derive ocean models, ocean circulation, we can do simulations. Here's just a computer model of the Gulf Stream system, and you can see some sea ice going back and forth. But understanding really means you're trying to discover some things, and then you're trying to say, what are the rules, how does it work, what are the phenomena, what are the mechanisms, what are the processes. It's the understanding. I think that people would expect our colleagues from in Frascati, from a scientist here at ESA, you not only discover, but you also understand. The problem with our understanding is, Annie and I and you guys, we like to publish and if you look at the literature list, if you go to our friendly receptionist in Frascati in the hotel and show her the literature list and ask her if she has read the paper, she probably says no. If you ask her, can you read the paper, she probably says, I have no idea. It's words that are not understandable to the non-experts, right? That's where we publish. So it's okay for us to inform ourselves, but it doesn't help our colleagues around society. So in order to do that, I think we have to work on assessments. So assessments, as Annie mentioned, for climate we have the IPCC, there's a World Ocean Assessment, different ones. So I would all encourage you to make sure when you do your science, also spend a little bit of time to translate your science in a language that is actually readable by non-expert, say, scientists, but also lay people, right? Because if you don't do that, then it's kind of hard to take advantage of what we've learned in the more societal context. Now, once you've done that, and we've done that with the IPCC, if you give a climate assessment that says sea level is rising, the planet is warming, but you still have to think about what is then the answer? What are we going to do? What are the solutions? Now, Annie didn't talk about solutions at all, if you noticed, right? She gave you the problem, but she didn't tell you what the answer is, right? Now, she made it implicit because you guys know what the answer is, but she didn't say that, right? I mean, if you don't like sea level rise, she sort of said, well, stop greenhouse gases now. You get enough even without them. But then the true solution in that particular problem is, how do we stop our emission of CO2? Now, that is a problem neither Annie nor I are an expert on, right? Now we're talking about energy systems, different types of science. I don't think ESA is an expert on energy systems. They can look at the consequences of that. There's different parts of society that we have to work with in order to the solutions. But if somebody has a solution, then Annie, myself, you guys can check whether the solution is actually a solution or just a crazy idea, right? So that's where system science comes in. At the end of the day, I think what we're trying to do, that's where we are today. On this axis, an imaginary scale of sustainability. We think it's low now. The 2030 agenda, I'll speak more in the middle, says by 2030, our development pathways should go through this. Sorry, it advances automatically. But I think we really want to be in this sweet and safe operating space at the end of the day. These solutions are the ones that I think everybody's looking to the scientific expert community like yourself. What could they be in the ocean, on land, between humanity? Not easy at all. So in 2015 and 16, I always say these were the good days of international cooperation. I'm not sure if the Paris Agreement would come up this year or the 2030 Agenda for Sustainable Development at the UN, whether this year we would have gotten as many countries signing up for it as we got 3 years ago, for reasons that you all know of and read in Twitter and so on. No. But these were interesting days, and so there was the Paris Agreement for climate, which I think we were very happy about, that at least the world has seen that there is a problem. Work from Annie's and the World Climate Research Program has shown at the IPCC. Now the leaders of the world say we should do something about it. And they say we should do something about it more than we will do something about it, right? And if you look about what we're actually doing about it, it's maybe not enough, right? But there's the other thing, which are called the Sustainable Development Goals. Who has seen the Sustainable Development Goals? Show your hands. I need you guys to do some exercise. Half. Okay, that's not so bad, but it could be better. So I gave you the version in comic form, right? Maybe you guys read comics better than UN documents. And there's 14 of them, and I'll get back to them in a second. And in simple terms, it's the to-do list for the planet, right? It's the kind of things you want to do. And here's what it is, the to-do list, right? It's about no poverty. We don't want people to live in poverty. Zero hunger, good health and well-being, quality education, gender equality, clean water. So, I mean, you can go down the list and you say, yeah, that's the kind of things we should be doing in our household, in our community, in our nations, maybe internationally. And, there's so what a great idea. This makes it really clear what needs to be done, right? Well, good luck with that. Let us know when you're done, and we'll throw you a party, right? So this is the UN saying, what a great idea. And then, hold on, aren't you part of that problem as well? And maybe we're in this all together. So I think the problem with the Sustainable Development Goals is they're developed at the UN level. Politicians of our countries, Germany is certainly one of them, signs it, very proud of it. You look at what happens in German politics, they never mention it again, right? So they'll say, good luck, UN, tell us when you're done, we throw you a party. That wasn't the idea, right? The idea was that we are all in this together. Good, so now let's take these Sustainable Development Goals a little bit into bits and pieces. So there's different ways to look at them. There's quite a few of them. In fact, I'm going to go back to this slide for 1 second, and then I'll switch forward again. So here are the ones in English language, and there are 17 of them. And I was part of the negotiation process to get them going. And as a marine scientist, Annie and I and son said, wouldn't it be great to have an ocean goal? Goal 14 showed up. So I talked to the diplomats in France, actually, also in Germany, in the US, and they said, yeah, the ocean is important, but we'll do it cross-cutting. It's important for food, it's important for transport and so on. We want to stick to 10 goals. So they were not happy about this. And France was unsure. They said, well, maybe, maybe not. US was a bit unsure. Germany was dead against it. UK was interestingly enough against it, and some others. But then we're at the UN. So the United Nations, it goes by voting usually, and usually means big resolutions like this one, they have to pass with everybody agreeing. Now there's some countries in the planet called small island development states, places like Madagascar, places like the Fiji Islands and so on. And they decided, wow, if there will be not a goal focusing at the ocean, there'll be no attention paid to us, right? Now, there's quite a few of them, 20 or so, small island development states. So they decided, you know what? We're just going to gang up and tell the UN colleagues of the rich countries like China, Germany, and France, and so on, no ocean goal, no vote. Ever since then, Germany loves the ocean goal. Not because they love the ocean goal so much, but we do love the small island development countries. Why do we like them? See, Germany likes to have a seat in the Security Council. We just got it in June. But in order to get a seat in the Security Council of the United Nations, you need the vote of nations. One country, one vote. China, one vote. Palau, one vote. Well, it's much easier to convince Palau that Germany is a great country by supporting the SDG 14 than swinging the vote of China. So Germany does a lot with smaller development states. It was a pure horse trade, right? So that's how they came about. Very interesting process. I can tell you many stories about that. So here they are. We have 4 goals focusing on the biosphere, one on ocean, one on biodiversity, one on climate. 3 mainly, and then there's one more on water you can count in there if you like, on fresh water. There's quite a few on societal, there's few economic goals. So clearly, you can separate them like that, but there are 17 goals, and the 2030 agenda is really the planetary societal to-do list going into the future. Now the question is, how do you know what happens? So here's a graph that shows you how we are doing for OECD countries and African countries against these SDGs. So they are listed here: hunger, no poverty is over here, ocean is here, these are the environmental goals. And what I find fascinating, if you look at some estimate, it's not a perfect estimate, of the environmental goals in the rich countries, the OECD countries are all red, we're not doing so well. Well, in Africa, they're pretty green, actually, the environmental goals, while Africa is doing really terrible on things like food, poverty, and so on, while the OECD countries obviously are doing well. So it's really interesting how the agendas are different, right? So for us, the environmental goals are hard, while the societal goals are easy. For Africa, the societal goals are hard. The environmental goals are maybe still okay. That will change soon, I can guarantee you that. So I just highlighted here the environmental ones in this bar. Now, the challenge with Sustainable Development Goals, they're just goals. So how do you make progress against the goals? Well, you define targets. So each goal is about 4 or 5 targets. In ocean, it says stop illegal fishing, do something about ocean acidification, stop pollution, things like that. But then once you have a target, you need to measure progress. How do you measure progress? You need an indicator. You need a number that says, am I doing better or worse, right? Politicians look at your unemployment rate in your country. If it goes down, they're happy. If it goes up, they're not, right? They look at other quantities like, how is your currency, if it goes up, or economic power, things like that. So these are targets. And the problem with this agenda is there's 17 goals and 159 targets, indicators. There's 160 targets and 170 indicators. Now that's a long list. And they're looking to you to help you with measuring these, right? They're looking honestly to space observations as one part of the solutions. I think scientists should be a bit smarter than that. They should also be able to think about whether all the indicators are independent. Could there be headline indicators, things like that. So there's a lot of work around indicators, but the data behind that, some are societal data, but a lot of environmental data. I think remote sensing offers a lot of opportunity in that space to act there. So for me, I think there's lots of opportunity here for innovation, integration, collaboration, and observing against this agenda. Now, Annie has shown you the space piece. So in space, that's just the European version. I think we're having Europe in many ways through the Copernicus, the Sentinels, is probably world leading these days in sustained space observations for environmental parameters. So it would be very obvious that European actors like you guys would really also be world leading in developing the indicators or the measurements for sustainability based on space products. I also like the science missions, so does Annie, because that's where we learn new things, we discover new things, but it's really this Copernicus sustained missions that's going to be so helpful for documenting sustainability. But that's not the end of it. Space is only so good, and certainly you need in situ systems. I'm using the ocean again as an example, but it's also true terrestrial. There's many things in the ocean you cannot do from space. That's also true with the terrestrial environment. And as Annie gave you a good example, sometimes you really have to check on your space systems whether sensors drift and things like that. So these things go hand in hand, and you really need both of them. But what I want to show you is you can also make progress by big data. So here's an example which I personally find quite exciting. It shows you with these light, bright colors where fishing happens, and when it's darker blue, it does not happen. So how do you know whether fishing vessels are fishing? The way this was done, most boats today have a mandated transmitter on board for navigational safety that transmits the position of the boat and the speed. That's to avoid collisions and a collision avoiding system. Now these data, they're not transmitted very far, maybe 50 kilometers around the boat, but they can be picked up by satellites. So, and satellite companies pick them up, and if you want them, I needed them recently, they sell them to you for a high price. So here's a nice cooperation with an NGO, so SkyTruth is one of those who sells the data. Google and Oceania did a project. Google bought all the data from SkyTruth and did the deep learning algorithms by basically saying if a boat goes from A to B, it goes in a straight line, it's probably trading. If it goes from A to B and stopping and moving around, it's probably fishing. So they used deep learning algorithms from that track data to detect when vessels were fishing and when not. So now you get a global map, you can look at it on the web of where vessels are fishing. It's a great tool to learn something about where illegal fishing is happening and where it's not. And what's interesting is bullseye. So here's a bullseye, not much fishing happening. There's a few in the Pacific. Here's one. These are the few stations with their fishery patrol vessels. St. Helena, UK does that. In many other parts of the world where poor countries, small and developing states do not have fishing patrol vessels, illegal fishing happens everywhere. For the first time, we could document that. So it's another data set. It's not Earth observation, it's not in situ monitoring, it's using data that we do for societal reasons, in this case, collision avoiding, that we can use to measure new things. I'm going to spend a few minutes on talking about what I call the ocean value chain. You can call it environmental value chain. And I think it's important for us to realize as scientists how I think our contract works. We all get paid by government months, most of us at least. So I think what we like to do is observing, discovering, mapping. That's sort of what we do. And ESA, Earth observation, that's very much core of this house and this group's business. And then at university research center, we try to understand what we see. We try to process the data, turn them into why is it happening, and I think Annie gave a great example of that. And if you get lucky, you take that understanding of the processes and do predictions and modeling or proper assessments. And again, Annie gave great examples of the assessment part. She didn't give you the predictions of sea level rise, but you know they are there, and the IPCC does that. So this is within the scientific enterprise. You know, you publish papers in Nature or Journal of something or other, and this is how our value system works. But as I said before, in the societal or policy arena, they're happy for us to do it. They give us professorships, and you guys get fellowships. But at the end of the day, they're looking for some output that they can read. And that is not your scientific paper. So, and that is where this assessing and informing becomes so crucial, because it's only when you've done that that the society around us is actually willing to act. And we've learned that, I mean, climate science has been going on since 25 or 30 years, but it's really only with the IPCC, which is a joint product of scientists and politicians, that it puts enough pressure in there that we could get to the Paris Agreement. So it was the assessment that made all the difference, not the Nature paper that Annie and her colleagues wrote. Because chances are that even your environment minister or ministress might not read Nature. So certainly that's true for Germany right now. But they will read the assessments. And even more so, they ask you, can you help me with this problem? And what they mean by that is, don't send me your Nature paper. They mean, send me something in 2 pages that I can read. Right? That's what they want from the scientists. Now, when you do that, though, and we've learned that also in the climate arena, quite often there's not enough information there to really be sure to act. They say, we need to know this better, right? So quite often this process then leads to new requirements for observing, understanding, and prediction. So it's a value system. And it's only when every element is in place that you actually get societal value. If you just do the observations and don't do understanding and prediction assessment, society will stop giving you the money to do that, right? So it's really important that we have this machinery running, and we are just a little piece somewhere in there as individual scientists. But it's always good to know what's out there. And in the new sciences that we do in Kiel, but also Future Earth, we're trying to connect these actors a bit closer, so we make sure that information flows more rapidly against certain agendas. That leads me to communication. So you notice that it is a lot about talking about what we know to the outside world, because we can talk to ourselves about discovery and insights, but it's also about communicating out. And so there's many forms and wisdom in that. And in the ocean agenda, because it was so new, the United Nations, pretty much a year ago, hosted the first ever ocean conference at the UN. I mean, the UN actually did the law of the sea, was the biggest legal piece, but that was just about the legal part of the ocean. But so it was an interesting conference I went to. I dressed up a bit for that. And I produced 2 pieces of information. One, I highly recommend. It's called the Ocean Atlas. If you want to Google it, ocean-atlas.org. So we produced a 30, 40-page document. It's like a magazine, like a glossy magazine, that on 30 pages puts together the challenges around ocean. I was amazed. There were 4,000 or 3,000 people there. That was the only document at the whole conference where the whole ocean agenda was in one. And people said, that's so great, Martin, do you have more? Because everybody else had their fishing document, their sea level document, their climate document, their biodiversity document. But we said we want everything in one, right? Because a societal actor is not going to pick up 15 different pages. They want it together. So that was kind of fun to have. But we also worked with your group and contributed. So one thing that you could do at the conference, you can make contributions and say, what do I got to do about ocean sustainability? So we contributed an activity that we have running in Kiel. It's a massive open online course. So it's not a summer school, unfortunately. It's an electronic version of that, of a summer school. And I'm going to show you the 2-minute intro video, and then we can say a few more things towards the end.
and endless. It encircles the planet, covers 71% of the Earth's surface, and provides more oxygen than all the rainforests combined. It holds unmatched and sometimes untouched natural resources, more than we could ever imagine. Here life began and has been sustained for millennia, harboring secrets we have yet to unlock. This is the ocean, the source of food and energy and the highway for international commerce. Its shores are home to 40% of humanity that lives within 100 kilometers of the coast. It provides sustenance, livelihoods, and links our global economy. But this is also the ocean, a vast yet finite system, bearing the telltale signs of our careless lifestyles. It is highly stressed through our growing interventions and is groaning under the burden of pollution and climate change. How can we be good stewards of our planet so that we and future generations can live in harmony with the ocean? Can we use our understanding of the ocean system and human system to change our actions to support human life within safe limits so that the ocean can continue to sustain physical services for us as it has for so long? Come join us and learn about the ocean and what it means to you. When we put our knowledge together, can we use ocean system thinking to arrive at more sustainable, smarter interactions and solutions leading to better governance?
So this particular course we've put together with another outfit. It's called Sustainable Development Solutions Network. And before I speak about the decade, it was fascinating. We ran it twice, 2 years ago and last year. Each time we had between 3,000 and 5,000 people sign up for it. With every massive open online course, about 10% come to the end. So a lot of people check it out. They do 1 or 2 lectures and say, it's not for me, that's all right. But we also had an active forum supporting it, and in the forum, that's where all the action happened. So we connected people from Palau to South Africa, to India, to certainly Germany, Brazil, South Africa, the United States. And so what we're really using these type of courses for is for global capacity building on one, but also for global learning. Because there were a lot of people who said, yeah, I have this problem, but I don't know what to do. And then somebody else said, oh, yeah, I know what to do. And, you talk to so-and-so. So they were promoting their projects, sharing websites, ideas, and so on. So it's a fascinating way to deal with global problems by doing global classrooms or global solutions. And I'm sure there are better ways than doing a MOOC. But if you want to join, it'll start again in September this year, Ocean MOOC, you can look at it, and then you can discuss ocean affairs with your colleagues if you like. Another thing that the United Nations do, once in a while, they put out decades. Does anybody know some of the decades we're in right now? United Nations has decades of who knows? Who works on biodiversity here from the students here in the classroom? One. All right, well, you're a bit in the minority here. Right now we are in the decade of biodiversity for the United Nations, and it really helped the Convention of Biodiversity a little bit along. And in December last year, the United Nations General Assembly has made a decision that they will have a decade for ocean science for sustainable development starting in 2021, going to 2030. So it's a way to raise awareness for ocean science, to improve international collaboration, and to really make progress towards sustainable development. Because obviously everybody's concerned that we might not make these sustainable development goals by 2030. And we for sure will not make them if we don't talk about them, right? So the vision for the decade is to develop scientific knowledge, build infrastructure, foster partnerships for a sustainable and healthy ocean. And again, it's a frame that I'm using here for the ocean community. Similar frames do exist for the land use community, for the atmospheric chemistry community, for the weather type communities. You just have to watch out for them a bit. And the decade is really interesting. In Germany, all of a sudden, a lot more people in the ministry are interested in ocean. because they heard about the decade and Germany's going to do something about it. So it's sort of all of a sudden, now Germany wants to host a PrepCom. They want to invite everybody to Berlin, maybe to convince small island development states to vote us into Security Council, but that's all right. So things like that can help to really muster interest in what we do. And I'm sure it will not be to detriment to ocean missions from ESA and Copernicus if the decade gets a lot of visibility, because then ESA and Copernicus will say, well, we're providing some of the baseline data, and the next 2 missions that are going to go up are going to do even more about that, right? So that's the kind of societal framework within which you can operate. Now, we do some stuff at home. I'm skipping over that for now. The next area I want you to think about is funding. Now, we all write our small grants. You haven't not even done that yet, but Annie and I have to do that. But sometimes it's actually helpful for you to write an individual grant if there's money in the system against an agenda that you want to work on, right? So, and right now we're working on the next range of big proposals for the European Union. And one of the things they talk about is missions. So, and again, they are realizing that in Europe we spend a lot of money around science, but maybe it's not leading to the impact that they were hoping to get. So now the newest game will be missions. We don't know exactly how they're going to go. There's some talk about them. And so, but there is an idea that the SDGs might be some of these grand challenges. So the reason why I'm educating you about sustainable development goals is in my estimate, in the next 5 years, you will hear more about them. And it's not bad to know about them and to a little bit how your research maybe connects to some of them. That just helps you to talk intelligently about what you do and why it's helpful. And this Professor Mariana Mazzucato, she's written one of the strategy papers, says, missions could make Europe cool again. I like the cool much better than the other word, right? So we'll see how we do. So the last 4 slides, I will talk about space. So I think we're here at an Earth observing summer school. It's about observing and modeling. But I want to share with you some of my thoughts about where space could be coming in here. First, I think innovation in space. I think we are seeing an enormous growth in the space-based ecosystem. And I don't mean numbers of satellites growth in an exponential way, but actually data that come from Earth observation get used in everyday lives. And I think the Sustainable Development Goals are one frame of that, economic development another frame of that. People sort of don't want to navigate so much in the blind. They want to more navigate in knowledge-based systems. And for that, you need knowledge providers. And space agencies like the European Space Agency is increasingly a knowledge provider. It's a data broker, not just a satellite agency. And I think that is where the growth comes in. And then the commercial ecosystem around it is going to secure space observations just as much as exciting birds and science do. I think the challenge will be, how can you create a sustainable space economy that's in economic terms, but also in environmental terms? So maybe, I'm sure you guys have some ideas. Technologies and ideas is what has always been great about space. New sensors, new advances. I mean, Annie showed you some great examples in that particular example of altimetry, you know, how you go from error from 1 meter down to 1 centimeter. It's a factor of 100 better in performance of the system. And things like that is what people associate with space. A lot of innovation comes from that. But also space, innovation in space is space in diverse markets. So it's the diversity, new applications from space, I think, that you will do in this coming 2 weeks. You come here with some application in mind, but I think you'll see what others are doing, and you see some innovation around here. And I think so there is a possibility to shaping and leading industry from the space perspective. Now, you are the scientists end to this, so they're looking at you for your ideas and innovation, but the agency sees that the amount of funds that space science gets needs to be justified economically, and they see great opportunities for us in the private sector, but I would also add into the government sector and civil society sector, because space information really helps us to call out bad behavior, to support good behavior, and things like that. Then I'll go to partnership in space. I think there is already a quite good partnership with Earth Sciences. We heard about the climate change initiative. There's many, we heard some about this morning about some projects with other research organizations that look at carbon fluxes in the ocean. That was the SOLAS community. I'm sure there's partnerships with many other, and several of you have benefited from that. I'm looking for more partnerships with environmental agencies. I think there are some, but I don't think we're at the end of the road yet. And again, these environmental challenges are going to come more and more and more. So I don't know what ESA can do about plastic. I just don't know. But I do know in society, plastic is the talk of the day. So if you had some insights from the ESA side of things, or in the lab this 2 weeks, if you can work something which relates to flows of plastics and so on, I'm sure people will be quite interested in that. But they really want to look for information products and delivery. So I think the labs that you'll be visiting, you're participating in this afternoon in the next 2 weeks are really towards that. It's the products. How can you use Earth observing in situ and space and tailor it into something that helps your science, that helps a commercial outfit, that helps civil society or government? Doesn't matter, right? It's at the end all products. And I do think that there will be an increasing call for integrated assessment. And why do I say that? Because this word that I hate, which is fake news, is all about the lack of assessment. If we have proper assessment, if we take our information about climate, not from the latest paper that's hyped in some sort of journal, but actually from what the World Climate Research Program done or the Intergovernmental on Climate Change, they're a little slower, but they're much more solid, right? Because they're taking many views into account. And I'll give you an example of good and bad assessments. In health, that's the place I don't want to be as a climate scientist. So in health, you can read in the papers over a period of 2 months, chocolate is good for you, chocolate doesn't matter, chocolate is bad for you. A glass of wine is good for you, it doesn't matter, it's bad for you. I guarantee you, every 2 months, you'll find in the media studies like that. Now, and you've read them all, you're laughing, right? But it basically means that information has zero credibility to you. That leads to the fact that people say scientists are fools. Today they tell me wine is good, tomorrow they tell me wine is bad, the word of the day, it doesn't matter. That does not help to build scientific credibility. What's the problem? It's an individual study done with no numbers in a certain context that then gets reduced to a nice media outlet story and is presented as science has told us. We should be pushing back and say, we don't want that. If you want to know what science knows, you go to the World Health Organization and read an integrated study of what alcohol does to your lifetime. That's the study you should read, and then the outcome is it's probably not so good for you. Right? So, and that's why I'm pushing so hard on assessments, getting away from individual papers. Individual papers, you never know, right? But assessments give you more credibility. And we're running the risk of being popular in science that we're losing credibility. I don't want to be in the field where nutritional science is. I really don't. I mean, that's the worst, right? And but we're getting there. People start pushing their individual piece, hyping it up, and then the outside world who's watching us for credibility, we're losing credibility that way. I don't like that. Open science, open data, cloud access. That is the safeguard against that. If your information is all in the open data, open science domain, then your study that told you the glass of red wine is good for you becomes very obvious that that's a selective study with a selective group under certain constraints. That's not the whole thing, right? So opening up the data set so everybody can look at them is really what helps you to be a better scientist, but also helps with credibility of what we do. And I do think is for ESA, big data discovery, analysis, and visualization, you see the tools this week in the summer school. That is something I think space agencies are well set up to do. And I would encourage space agencies to also ingest non-space data. Because at the end of the day, the scientists here in the room, they want information. They couldn't care less whether it's from an ESA-paid bird, a NASA-paid bird, a JAXA-paid bird, an Indian or Chinese satellite, or if it's in situ data, or as I said, you random societal data. At the end of the day, you want access to all that information that your estimate on food security, on biodiversity, on sea level, whatever it is the best possible. So my plea to the organization is, don't just sell your stuff, make everybody else's stuff available also, because the scientists will love your data portal even better if you can get all the satellite data from the portal and not just the ones that have your brand on them. Not for you. You guys do that very well. So last 2 slides here. Outreach. Now, I believe it's very important to have summer schools like we have here, because that's where we're building capacity. A lot of people think capacity building has something to do with underdeveloped countries. It does not. Capacity building means you're building capacity everywhere, also in our own countries, also in Europe. And to me, capacity building is training the next generation of scientists. Summer schools are doing that. I also believe at outreach, and that's why I showed you a movie or two, and we saw great this morning. We had a wonderful set of movies. So visualization and virtual reality is going to become more and more important. What do I mean by that? You guys have access to Earth-observing data sets. You can assess what's going on right now. You can show to the world what has happened over the last 20 years. Wouldn't it be cool if you can then also show them how your piece of real estate, let's say land use or rainforest or ocean, will look like in 20 years, 30 years, and 50 years, depending on your societal choice, right? Depending on, am I going to reduce my carbon footprint? Yes, no. If I'm going to, eat this or that or something else, if I go lower trophic level or higher trophic level in food supply, you say, okay, if everybody wants to become a meat eater, this is what the planet will look like. If everybody becomes a vegan, that's what the planet will look like. That virtual reality projecting into the future in a visible way, I think is really exciting for outreach, because it allows non-techie experts to engage with us in our science. So I think there's great opportunities here. Earth and environmental literacy, as I mentioned, this is tough stuff. You'll see in these 2 weeks, you come with a certain background in whatever your domain is, and will find it also challenging after 2 weeks to see all the other environmental elements, and it's only Earth observing, it's only one small sector of this. Imagine what else you need to know as a decision maker. So that literacy is really critical. And then pay attention to all the sectors: scientists, government, private, civil society. And I think for ESA, it's really important to have strong partners in civil society, as much as the private sector, as much as government. Yes, governments pay the bill, so you look at them first. But governments also pay attention to their civil society sector, so you really want to have partnerships with all of those. So my last slide, we saw the Space 4.0 before. I think it's really about innovation in space. So that's the growth of the space ecosystem, and I think you'll see a lot of examples in the next 2 weeks about that. The Phi Lab here and some other things here in Esrin. Partnership in space, I think it's really about partnerships, and I mean here partnerships internationally, partnerships between sectors, partnerships between data providers, data users, modelers, and so on. So lots of stuff for you to look at, and outreach in space science. I have a sidebar here that I didn't show too many slides, but I will say I was missing a little bit. It's been slowly changing now in the latest communication of ESA and Africa strategy. I mean, in Europe, it's very clear that in the sustainability concept thinking, we need to have a good strategy with Africa. Not for Africa, with Africa, right? That means, so ESA colleagues here, front row, how many ESA institutes, collaborations do you have in Africa? Take the microphone so they can hear you.
It's a very good question, also because I'm here. I've been working 10 years with Africa in a program that was called Tiger. And Tiger was a partnership with many African institutions, including river basin authorities, national governments, NGOs, universities, to support capacity building there, mainly in the context of water management.
Yeah.
This continues, has been there for 10 years, and the thing that we are trying to do now is to extend that towards maybe a more wide African vision, maybe addressing other topics like agriculture, urban expansion, etc. So it's there, has been there for many, many years. Yeah.
So make it more in the limelight, and I would challenge to all of you guys, summer school students, as you go to the next 2 weeks, when you think about your own project, your science, how can I apply that with colleagues in Africa? How could I get African partners involved? And again, I'm not asking you to do something for Africa. I'm asking you to do something with Africa, right? So think about that a little bit. All right, that's the end of my talk for before lunch, and happy to take questions, and I'll say more about oceans afterwards.
Okay, we have one question here.
Hello, thank you. My question actually is related to what you said earlier about Africa when you had the OECD countries and the continent of Africa in terms of the progress for the SDGs. So is Africa only better at the SDGs goals related to the environment because it's not doing that great in the first ones? So basically, when economic development, like prosperity happens and people start spending more, is it just lack of consumption patterns compared to the West, rather than kind of proactive policies related to the environment?
I think that's a great question. I think the answer will be much more complex. I think at the end of the day, what you're seeing here, there is still some vast space in Africa that is not heavily used. That's shrinking very slowly. So that's why there is a bit more biodiversity and so still there. But if you look more carefully into some African regions, you don't see that anymore. So it's in fact, what you actually see in some of our areas, there's recovery. And by most African regions, it's only decline, but they're starting from a different baseline because it didn't have that much development in the first place. So you're absolutely correct. So we're trying to, limit a bit our footprint. And while in Africa, in many regions, you're starting off with a not so heavily used environment, but you have to be really careful. That is going away very, very quickly. In part also because of our actions. We're exporting a lot of our stuff in trade with Africa and so on. But yeah, so semi-true. Certainly a shorter development history helps you in preserving the environment. So the question is, can you have a long development history and still preserve the environment? That's the question. I think there's one. No?
Is there another question?
Where's lunch?
Okay. Right, so now we will break for lunch, and the lunch